and welcome to 7.5 Operations with Matrices. All of these are well worth. I'm going to give you the opportunity to take some screenshots or take a look at these, and you can pause. All of these things are well worth looking at, but what we're going to find through looking at these and these is that pretty much addition, subtraction, everything is just exactly like we would expect it to be in matrix land. It's pretty familiar. You see commutative properties, associative properties, identity properties. Matrix multiplication, the properties there should look pretty familiar, seem like what we're used to dealing with. Addition, subtraction, super easy in matrices. Multiplication, a little bit squirrely, and we'll go through some of this. One thing I do want to comment on before we get into the problems is if we had a matrix 4, 2, 1, 7, negative 2, 3, 5, 0, it's important to recognize the order of a matrix, and the order is just the dimensions of the matrix, and this is a 2 by 3 matrix. 2 rows, 4 columns, or excuse me, that was silly, 2 by 4 matrix, 2 rows, 4 columns. So if you look back over here, this A13 just refers to, we'd probably identify this as entry 1-3, where 1 is the row, 3 is the column. That way we can talk about individual entries within a matrix. A matrix is just a rectangular array of data. Okay, but I'm going to just jump right through. They've got an identity matrix down here. I'm just going to jump right into the example problems. I got a tight window here of time, and I want to get this out to you. So let's take a look. Here we have a 3 by 3 matrix that's stated to be equal to a 3 by 3 matrix. In order for that to happen, every corresponding entry has to be equal. This wouldn't be true if this was 8 and this was 7. It wouldn't matter what X, Y, and Z are. Every single entry has to be equal, but X plus 4 must be equal to the entry 2X plus 9. If I subtract 2X on both sides, I get negative X. If I subtract 4 on both sides, I get 5. So X is negative 5. Likewise, by the time we get to Y, 2Y corresponds to negative 8. So Y is negative 4. And Z plus 2 equals 11. This is a chance for me to get on my soapbox and say, please, when you're using Z's, cross them so they don't get confused with 2's. Even if you loop your 2's, which I don't, please cross the Z's. So Z is 9. And for whatever reason, when I put these sheets together, I do this with a lot of copy and paste, and we're going to go counterclockwise here this morning and take a look at number 14. So we want A plus B. Vector A plus vector B. Worth noting also that if you see a capital letter in this chapter, they are referring to, yes, it's a variable, but it's a variable that stands for a matrix. A plus B, it's exactly what you would probably suspect it is, and I'm going to do this just one time. We just add the corresponding values. 1 plus negative 3, 2 plus negative 2, 2 plus 4, and 1 plus 2 for a final entry of negative 2, 0, 6, 3. B. Now we're to subtract the matrices, and we subtract those in the same manner. A minus B is, and I'm not going to write this one out, it's so simple. 1 minus negative 3, 4. 2 minus negative 2, 4. 2 minus 4, negative 2, and 1 minus 2, negative 1. C, we are to find 3 times matrix A. This is called a scalar. You might have saw that word on the previous page. The 3 is a scalar. It just scales the matrix. It makes the matrix 3 times as big as what it was, and is probably exactly what you would guess we need to do. We just take 3 times each entry. 3, 6, 6, 3. And you should note then, likewise, you could just factor out 3 and use this to represent that. It's really useful when we get into some fractional answers, and you'll see that as we proceed. And D, this would be a really good time. This is the way we handled this in class, and it went very well, for you just to try to do this on your own. Pause the video. Try to find 3a minus 2b. So we've got 3 times a, which we already know is 3663, minus 2 times b, that would be -6, -4, 8, and 4. And careful, we're subtracting those, so we get 3 minus -6, that's 3 plus 6, 9. 6 minus -4, 6 plus 4, 10. 6 minus 8, -2. And 3 minus 4, -1. And 20 is my kind of problem. We cannot add this. This is a 3 by 1, 3 rows, 1 column. This is a 1 by 3. They are not of the same order. We cannot add those, so not possible. I don't know why I put 20 there, not A. A, we're supposed to find A plus B. B, we're supposed to subtract them, not of the same order, not possible. C, however, we're supposed to take 3 times A, and that's easy and possible. 9, 6, -3, we just scaled it. And D, we're supposed to multiply 3 times A, we can do it. Multiply 2 times B, we can do it. But we'll still have 3 by 1s and 1 by 3s. We cannot subtract those. Not possible. Okay, back up to 26 here. We're going to use our matrix capabilities in matrix right here, x to the -1st, it's second x to the -1st. So we're going to go second matrix, and I might already have these in here. And we're going to edit that first matrix. And you would just enter, I'm going to go through the process anyway. You'd enter 2, and then we could enter 14, enter the -11, etc. until we get our matrix A entered. I'm going to go back to matrix. I'm going to go to matrix B. And matrix, whoops, wait, I need to quit first. Second matrix. Edit matrix B. I don't think I didn't get to edit. And I have it entered, -22, 20, 13, 6. And then we can quit out of here. And then to solve this using our matrix capabilities, 4 divided by 5 times second matrix, just select A, plus 7 times matrix, select B, and just enter the B. You hit enter, you have it. They started in fractions. I'm going to go to fractions. So we're going to go math fraction. And we get -714 on 5, 656 on 5, 367 on 5, and 286 on 5. It's very common in matrices when you do operations to get results that have common denominators or maybe very, very similar denominators, where this might be a 10 or a 15, where you have a real nice, easy common denominator. This is perfectly acceptable for an answer, but I would suspect maybe the back of the book would do this. You might want to do this as well. Might want to just factor that 1/5 scalar out. Okay, now multiplication. And when I made this, I meant to leave more space. In fact, I meant to bump these to the next page, but for whatever reason, they did not bump to the next page. Multiplication, as I said earlier, is a little bit squirrely, and we can actually multiply these even though they're not in the same order. And here is the deal. And in class, I said you really want to laser focus on this one. People don't struggle with the addition and subtraction and scalar multiplication, and you can see why based on what we just did here. But they do on the multiplication by hand. So this first one, A, is a 3 by 2. We're multiplying that by B, which is a 2 by 2. We can't always multiply matrices together, but we can under this one condition. These have to be equal. If these are equal, we can multiply it, and also we will end with a 3 by 2 matrix. And here's the way this works, and On this lesson, I'm not going to explain to you why we multiply these this way. This is just going to be the mechanics, but that will come when I do the second half of this video with you. So I'll use my fingers at times, but I'm going to use my pens to illustrate this. This row is going to go to this column, and then this row is going to go to the second column, and then row 2 will go to column 1, and row 2 will go to column 2, and row 3 will go to column 1, and row 3 will go to column 2, and that will give us 6 different answers that make up our new 3 by 2. And here's the way this works. A equals. A lot of times I'll use, I want a little taller one than that. A equals, a lot of times I use my fingers. I'll take these values right here, multiply them by those, and add the results. I'm going to write it all out one time. I take -1 times the 2 plus 6 times the 0. And since that's row 1 times column 1, that's my row 1, column 1 entry. Now I got really two viable options where to go. I could take these times these, -4 times 2 and 5 times 0. If I did, that's row 2, column 1 would go here. But I'm going to go across. -1 times, this is row 1, column 2, it's going to go here. Row 1, column 2 of my result. This is A times B. -1 times 3 plus 6 times 9. -4 times 2 plus 5 times the 0. Again, it might help you to do the finger thing. And now would be a really good time for you to pause the video and just complete this. We got 3 more entries to get. Row 2, column 2. Row 2, column 2, -4 times 3 plus 5 times 9. 0 times 2 plus 3 times 0. We like zeros in these. And 0, row 3, column 2, it goes row 3, column 2, 0 times 3 plus 3 times 9. And now we just have some easy computations. -2 and 0, -3 and 54, -8 and 0, -12 and 45, 0 and 0, 0 and 27. And there we have it. And now 42. 2 by 2s. Find if possible A times B. So this is a 2 by 2 times a 2 by 2. We can do it, and our result will be a 2 by 2. But we don't just take 6 times -2 and 3 times 0 and -2 times 2 and -4 times 4. So AB. Row 1, column 1. I get 6 times -2, -12, plus 3 times 2. Oh, that's not what I wanted to do at all. I'm going to replace this. Actually, I'm going to do this the way we did it in class. See if you can follow this. Let's do this one in our head. A times B. We get -12 and 6. -12 and 6, -6. Here we get 0, love 0, and 12. Row 1, column 2, 0 and 12. Here we get 4 plus -8. Row 2, column 1, 4 plus -8, -4. 0 and a -16. So there's AB. Now, to find BA, you could do this backwards, but I would highly recommend, let's write A over here, 6, 3. I've been doing this a long time, and I still find this very helpful. So A times, or B times A, 2 by 2 times 2 by 2, we're going to get a resulting 2 by 2. We get -12 and 0. Row 1, column 2, -6 and 0. 12 and a minus 8. 12 minus 8, 4. 6 and a minus 16, negative 10. And now let's wrap this one. Oops, I didn't want to do that. Wrap this one up here. A squared. And you can probably guess what common mistake is for a squared. A squared, people just come in and they square this. They go 36, 9, 4, 16. But a squared means a times a. So that's 6, 3, negative 2, negative 4 times 6, 3, negative 2 times negative 4. I'd like you, if you would, please just pause this and go ahead and give this a try, and then start the video back up. We get row 1, column 1, 36 and minus 6. Row 1, column 2, 18 and minus 12. Row 2, column 1, negative 12 plus 8, negative 4, and negative 6 plus 16, 10. And definitely worth noting that, let's see, these answers are not the same when we take AB times BA. That's what I really wanted to point out. And again, this is certainly not 36, 9, 4, 16 when we square. Okay, we definitely have more to follow, and you will find out in the next video when we go ahead and explain, or you'll get a chance to see an example of why we actually multiply things like this. It's not just a computational exercise for us. Okay, as always, you're going to let me know if there's anything I can help you with, and stay tuned.